be on electrochemistry revision. Yeah. So we have already done our part on this electrochemistry. But there is another one part that we will cover towards the end. But we will go through some questions over here. So you can see here. We will start off today's session with a question on this. Yeah. So which is going to be draw a fully labeled diagram to show how the standard electropotential of X2 plus and X. So if you look at this, automatically you should know that this is going to be something related to your metal cation, and we are going to find the standard electropotential. So in order to find the standard electropotential, you need to compare with the hydrogen half cell. So you need to draw the hydrogen half cell. So you make sure you draw something, a tube like this, a glass tube, and then you put the platinum wire. Platinum will be there. And then you have the beaker, and then you have the solution. And then maybe here there will be some hole over there, but it's not so important, but I will still put over there. And make sure that it's going to be maybe here something like this. And then let me erase this part. So you draw maybe something like this. This one is up to here. This is platinum. You are going to supply the hydrogen at 1 atmospheric pressure. Over there. And then this wire is going to be connected to voltmeter. And this is going to be, you can say platinum wire. This is going to be platinum. And this is going to be the H plus, which is going to be, you can select maybe HCl, aqueous, at 1 mole per dm cube. So this is going to be the half cell. So every single time when you draw, you are comparing, with this hydrogen, and maybe I'll just save this maybe for our future reference over here. I'll just copy. Probably I will save it here first. Maybe later we will use that, because most of the questions, they will ask about this. So now we are going to find out, between the X and X2 plus. So the one over here, the electrode, is going to be the X electrode. This is the electrode. And then we are going to have the beaker, and you are going to have the solution. The solution is going to be containing X2 plus ions, which is aqueous at 1 mole per dm cube. And make sure, you complete the circuit, by drawing the salt bridge. So this is going to be the salt bridge, and this salt bridge, must be soaked, soaked with sodium nitrate or potassium nitrate. So that is salt bridge to complete the circuit. So this is going to be a diagram. How do you measure the standard electropotential? And then if they ask you what are the conditions needed for the value measured to be a standard electropotential. So if you want to find out the condition, this one you memorize only. I think the standard electropotential, it happens at 1 atmospheric pressure. And it is going to be done at 298 Kelvin. And all the solutions that you use, must be having the concentration 1 mole per dm cube. So you make sure you mention all these three. And then they say, state the charge carriers that transfer the current through the solution. So through the solution and through the salt bridge, remember, it's going to be the ion. Or you want to be specific. The ions are X2 plus and H plus. Those are the ions that are available in this particular setup. And then in wire, through the wire, what is going to be transferring the charge? The one is going to be electron. Electron is going to transfer. So don't forget about this. The movement of the electron, they ask, the movement is going to be through the wire. If there is going to be salt bridge and they ask you what is going to move over there, that is going to be ions will be moving. And of course, you can actually check, okay, the marking key. Marking key is given over there. You can check whenever you do it on your own. Now, the next question is going to be an electrochemical cell, okay, was set up using this, and then they have given you, okay, the half cell, okay, the E value is negative 0.4. So I've written over here negative 0.4. And then you have silver ion and silver half cell, which is going to be 0.8. So I've written, okay, always when you write down the half equation, you write down in form of reduction. Okay, it means adding electrons. So I've written down in form of reduction. And if they ask you write an equation for the reaction that will take place, if this is going to be connected. So based on what I taught you, okay, you look at the E value that is going to be the more positive. You see negative 0.4, positive 0.8. This is more positive. More positive will go to the right. The one that is going to be left positive or negative, they will go to the left. So if I want to rewrite this, I will rewrite this Ag plus electron to give me Ag, because following the right direction, so the E value is 0.8. And this one is going to be, the first one is going to go to the left. So I will write down X to give you X2 plus 2 electron. The E value now, because it's going to the left, so negative will become positive. So positive 0.40. So if I want to find the E value, if you add, you just need to add, it's going to be 1.20 volt. Okay, and then if I want to find out the equation, okay, you need to balance the equation. So you see the electron, 2 electrons, so you need to times this by 2. So this one is going to be 2. Do remember, don't go and times this by 2. Okay, this is another common mistake that students always do. Okay, don't do that. Okay, and then you just add, okay, the electron will be gone. You will have 2 Ag plus X to give you 2 Ag plus X2 plus. So this is the one that they are asking. Write the equation. Okay, the equation that you write is 2Ag, okay, plus X, okay, to give you 2Ag, okay, plus X2 plus. Mr. Gopi, do we need to write the state symbols? If you have doubts, okay, just write. Okay, if you have doubts, okay, no need to ask me. Just write. Okay, this is going to be aqueous. This is going to be just, we are assuming solid because there's now electrode, right? So solid, and this is going to be solid, and this is going to be aqueous. Okay. Now, the next question is, okay, when the current was allowed to pass for a period of time, okay, the silver electrode gained mass of 1.3 gram. And then they say the electrode made the metal X lost 0.67 gram in mass. So we want to calculate the relative atomic mass for metal X. Okay, and then we need to suggest. Now, do remember, this is slightly different than your Faraday calculation. Okay, because, okay, why I do not use Faraday calculation over here? Because they didn't specify the period of time. They didn't specify what is going to be the electric current. They didn't specify that. So you need to think, okay, what they are trying to get over here. So first, okay, the first thing that you can work is going to be silver electrode gain in mass. So find out how many moles of silver is that. Okay, so you look at your periodic table and then relative atomic mass of silver. Okay, you can see silver is 107.9. Okay, you can see from the marking key here. So you find the number of moles. Okay, so if I find the number of moles, I will get 0.012. Okay, so I'll just put 0.012 moles of silver. Now, if I have that, okay, and I have the equation that is happening. So if you have 0.012 moles over here, and I want to find out how many moles of X will be reacting, because one will be gaining mass, another one will be losing mass. Yeah. So I can calculate what is going to be the number of moles of X. Okay, which is going to be with the ratio of 1 to 2. Okay, so half of it. So it's going to be 0.006 moles. And now, okay, I can calculate, okay, because I know number of moles equals to mass over AR. Okay, number of moles is 0.006. Okay, the mass, I know the X, the loss of mass is 0.67. So I just put 0.67 and I can calculate what is going to be AR. And if you calculate, okay, the AR you will get, okay, I'll just straight away look over here, roughly around this, 111 to 112. So if you, let's say I just take 111, if you go and look at your periodic table, okay, and you look at the relative atomic mass, you will get that the identity of X is going to be cadmium. Okay, you can do it on yourself. Okay, this one is not using Faraday calculation at all. Okay, this is straight away using the equation that you have balanced earlier. Yeah, simple. Okay, let's move on. Okay, if let's say they ask you this question, this is very, very popular. Okay, they say, what is meant by the term standard electrode potential? What is standard electrode potential? To answer this is very simple. Okay, potential. Okay, we are not, if you are not actually studying physics and so on, it's okay. How do you answer this? Is the potential, okay, is the potential standard electrode potential. So it is compared to hydrogen cells. So it's the potential, okay, of a half cell, okay, in reference to hydrogen half cell under standard condition. And you can write down, okay, it's going to be 1 atmospheric pressure, 298 Kelvin, okay, and then you can say the concentration of H plus or the concentration of the electrolyte. Okay, you can mention that the concentration of the electrolyte is going to be 1 mole per dm cube. Okay, you can just add to it. Okay, that will be 2 marks. Do remember, okay, past year papers, okay, most of the time they give you 1 mark, okay, but only I think on certain conditions they give you 2 marks. But what they are expecting from you is, okay, you tell, okay, this is potential in reference to hydrogen half cell, okay, and then it's under standard conditions. So for this particular question, yeah, they want you to mention about this, and they want you to also mention about this, okay, in order to get the 2 marks. Now, draw a fully labeled diagram, okay, of the apparatus you could use to measure the standard electrode potential of Fe2 plus and Fe3 plus. Now, remember just now I said this, okay, this is going to be helpful for me. Okay, I'll bring it over here and I am going to paste it over here. And okay, I'll just put over here because why? Because I am comparing to the hydrogen cell. Okay, so this one, I just need to draw the another part, which is going to be the one that is going to be connected to this. But remember, okay, Fe3 plus and Fe2 plus, this is going to be what kind of cell? Okay, because I taught you about 3 different cells, okay, half cells, which is going to be metal, metal ion, non-metal and non-metal ion, and ion, ion. Yeah, I hope you remember the previous lecture. So anyway, okay, if you compare, okay, do remember, okay, this one, okay, is going to be for ion, ion. Students will go and draw electrode of Fe. Wrong. Okay, ion, ion, the electrode that you're supposed to draw is going to be platinum. Okay, and then you put this, and then you put the solution. Okay, and then this one is going to be Fe2 plus together with Fe3 plus at 1 mole per dm cube. And then you label is platinum, okay, voltmeter, okay, I think the others, but do remember, okay, to include the salt bridge. Very, very important, okay, quite simple, you see, you need to draw. And one thing that you need to take note is drawing, you see, 5 marks, okay, 5 marks. You look at the drawing over here, 4 marks. Okay, as easy as that. Okay, you should know now. Okay, 4 marks and 5 marks, they are a lot. Okay, so you can gain a lot of marks. Okay, so make sure you know how to draw. That's why very important how to draw. Now, the next question is going to be the reaction between Fe3 plus ions and I minus ions in an equilibrium reaction. Yeah, it's given by this. So they are asking you to use the data booklet to calculate the E cell for this reaction. So before you start or before you want to go and look at the data booklet, you just need to identify what are the ions that are involved in this equation. So I know, okay, this is going to be the ion. So I need to look for, okay, equations involving Fe3 plus and Fe2 plus. And I need to look for equations involving I minus and I2. So when I go and look at my data booklet, I will get the value, and I have already looked for you. Okay, you just need to refer and you need to get these values. And do remember, I'm taking directly from the data booklet. I didn't make any changes. I wrote, okay, the equation under standard reduction potential. You see, all these are standard reduction potential. And then I have all the data. Now I need to calculate. This one, you just need to use whatever things that I taught you. You identify between 0.77 and 0.54, which is going to be more positive. So you know that this is going to be more positive. Therefore, this is going to go to the right, and this is going to go to the left. So if I want to rewrite this equation, I will rewrite this as Fe3 plus electron to give me Fe2 plus, and this is going to be 0.77. This is going to be 2I minus to give me I2 plus 2 electron because I reverse the equation. So therefore, this is negative 0.54, no longer positive 0.54, negative. So if I want to find the E value, okay, don't make the mistake, because I want to eliminate the electron, I need to times everything by 2. So I go and times this by 2. Don't do that mistake, okay? This is wrong. You don't do that, okay? You just need to change the symbol, the sign, okay? But you do not need to times with anything. So when you calculate this, okay, 0.77, okay, minus 0.54, you are going to get 0.23. So which is going to be a positive value, 0.23 volt. Okay, so they want you to find, okay, the E value. So I already calculated. Okay, so this is going to be positive 0.23 volt. Okay, done. Hence, okay, state with reason whether there will be more product or more reactant at equilibrium. To answer this, very, very simple. If your E value that you calculated is positive 0.23, okay, positive, they will go to the right. If it is negative, they will go to the left. So this one is going to go to the right. Therefore, you can just conclude that the position of the equilibrium is actually towards the right, which is going to be towards more product. Okay, you can identify based on the full equation, or you can even identify directly, okay, from the half equations. Up to you, up to you. Okay, but in this case, okay, this is going to be 0.23 positive value, so they will be more towards to the right. So more product, and explain what is the reason, because the E value is positive. Okay, so if you don't believe what I'm saying, it's so easy like this, is it? Okay, this is going to be the marking key. You see, 0.23. Okay, since E is positive, therefore it's shifted to the right, or product is favored. That's it. Okay, you do not need to worry so much about it. So very simple. Okay, you just need to calculate properly. That's it. Okay, make sure you calculate properly, and you should be able to get the answer. Okay, next question. Okay, you see, this is going to be another question. They give you, okay, a chlorine gas and then iron 2, okay, Fe2 plus, react together, and they give you an equation. And then they ask you to complete and label the diagram, okay, to show the E cell. Now, if you have this, I know that this is Cl2 and Cl minus, and I know this is Fe2 plus and Fe3 plus. So Fe2 plus and Fe3 plus is going to be ion-ion. Cl2 and Cl minus is non-metal and non-metal ion. So therefore, you see, when they ask you to complete, this one is already in the question paper. Okay, so if they ask you to complete, of course, this one belongs to Cl2 because iron is going to be ion-ion. Okay, so this is going to be the Cl2 will come in at 1 atmospheric pressure. This is going to be your platinum wire, and this is going to be your platinum electrode. Okay, electrode. And do remember, what is this? Cl2. So it must be Cl minus, or you can say maybe I'm going to use HCl. Okay, up to you, or NaCl, up to you. Okay, so let's say I'm going to use NaCl, for example, here. NaCl, okay, aqueous at 1 mole per dm cube, as long that Cl minus is there, okay. And then I'm going to continue, okay. I will add a line over there, a wire, okay. So voltmeter. Then I'm going to connect this, okay. Do remember, it's ion, Fe3 plus and Fe2 plus. So you just need to have a platinum over there, and then you put the beaker, okay, and then you put the solution, okay, and this is going to be Fe2 plus with Fe3 plus at 1 mole per dm cube. Always remember, for ion, always check whether there is going to be H plus or not. Yeah, in this case, you can look at the half equation. There is no H plus, so no need to worry about that. Okay, so that is going to be the solutions involved. Okay, and then complete the circuit by drawing the salt bridge. Okay, salt bridge. That's it. Okay, done. And use the data booklet to calculate. This is the part where you are going to use the data booklet, and I have already took the value from the data booklet. Directly from the data booklet, you will get these two values. Okay. Now, does the wire have to be always be platinum? Okay, good question. Now, this one, according to the textbook and according to the past year paper answer keys, yeah, most of the time they put platinum, okay, but I don't see any reason you cannot use carbon, okay, or graphite, okay, but I will suggest, okay, always use platinum, okay, always use platinum. So I hope that answers your question. Let me check the chat as well. Okay, only that one, okay, only that one question I've already answered. So you remember, okay, it's going to be platinum. Okay, does it always have to do? Okay, my answer is, okay, according to the past year questions marking key, it's always platinum, and it's also written in the textbook many times. So let's use platinum. Yeah, let's use platinum. So here, okay, use the data booklet to calculate the E cell. Okay, so to calculate this, okay, you get all the values first and find out, okay, whether this is going to be, which one is going to be positive. I know this is positive, so this one will go to the right, and this one will go to the left, okay. So I rearrange it. So Cl2 plus 2 electron to give you 2 Cl minus. So that is going to be 1.36. And Fe2 plus, okay, will give you Fe3 plus, and then plus electron, because I rearrange is negative 0.77. And then, okay, do remember, even when you go and times, okay, by 2, because I want to eliminate the electron, you don't go and times this by 2. Yeah. Now, okay, I will answer that question in a while, the chat. Okay, you just join these two together. Okay, so when you join these two together, it's going to be 1.36. Okay, you minus 0.77. So this is going to be 9. This is going to be 5. Okay, 0.59. Yeah. So you will get a positive 0.59. Now, so this is going to be positive 0.59. Okay, you just use 0.59. Don't simply write 0.59 just like that. Okay, whatever that I do the calculation over here, okay, this thing, okay, should be coming over here. Okay, you must show all your working. Okay, just for this, okay, I'm leaving a space over here so that I can write it down. Yeah. Now, there is a question, okay, whether we need to write down, okay, which one is positive and negative. The answer is, okay, it's not necessary. Okay, it's not necessary unless they ask you to identify. But if you have find out and you want to write down, it's up to you. Yeah, it's up to you. So Chris, you can use, okay, you can use, if you want to find, you already find out the E value, and you know, okay, you know that Fe2 plus is the one that is going to be giving out electron. So Fe2 plus is giving out electron go here. So I know that this is going to be negative terminal and this is going to be positive terminal. If you want to write down, up to you, please write, okay? But it's not compulsory. Okay, will they go and deduct marks because this one is 4 marks? Okay, will they deduct marks over there? Not really. Okay, normally if they want you to identify which one is electrode positive and negative pole, yeah, they will ask you. Yeah, even the direction of the electron, if they want to ask, they will ask you. Then only you write. Okay, now next question. Okay, what color change, okay, would you see when chlorine gas is bubbled through a solution containing Fe2 plus? Now for Fe2 plus, okay, do remember Fe2 plus is green color. Okay, so when I have the green color, okay, we know that the Fe2 plus is changing into Fe3 plus. What I meant just now, okay, we stopped at okay Fe2 plus, okay, being green, okay, so Fe2 plus is going to become Fe3 plus. So you need to know, okay, what is the color change? Yeah, so Fe3 plus is going to be brown. Yeah, so the color change is going to be from green, okay, to become brown. Okay, do remember if you go and look at the marking key given, they say yellow, orange, or brown. Okay, so if you look at that, okay, please remember, okay, if you want to have a better answer, okay, so please answer green to brown. That will be a better answer for this question. Now, the next is going to be predicting the effect, okay, if any, decreasing the concentration of chloride ion. Okay, so if you want to decrease the chloride ion, what will happen? This one, if you want to answer this question, there are two ways to do. One, you can do an actual calculation. Another one is just by using the equation, you can predict. Okay, like just now, okay, in the previous example, you say, if you have chloride ion decreasing, okay, chloride ion decreasing according to LCP, Le Chatelier's principle, okay, you need to increase the chloride ion concentration. How do you increase ion concentration? By shifting the position of the equilibrium towards the right. How do you increase the what will happen to the E value if you shift the position to the right? Of course, the E value will become more positive. So earlier when we calculated is 0.59. So we are expecting the value to become more positive, okay, or more, okay, it's going to be more than more positive or more than 0.59. Okay, you can say exact value more than 0.59 volt, or you can say more, it will become more positive. Okay, more positive. Why? Because you can say this is going to be to increase the concentration of chloride ion back. Yeah, so that is the reason. But if you are not sure, okay, you want to actually find out from calculation itself, also can, okay, because you are going to decrease the Cr minus. If you decrease the Cr minus, okay, you see from the equation, okay, if you decrease this, okay, what will happen? Okay, of course, okay, the position of the equilibrium will move to the to increase the Cr minus. Okay, so I am going to expect this value from 1.36. Okay, it's going to become maybe 2.0. So when you have 2.0, okay, 2 you minus with this value, okay, what will happen? Okay, so of course the value is going to be greater than 0.59. So you can use the calculation, okay, to predict this as well. So up to you which method you want to use, but in the end, okay, in the end, the answer should be more positive, okay, and then you mentioned that, okay, it will be shifted to the right, okay, because you want to increase the concentration of Cr minus. Okay, so whatever it is, you can see, okay, it will become more positive. Okay, the electrode potential increase. Okay, we have mentioned more than required. Okay, so if we move on, okay, when you look at all the examples that I've given you, okay, before the blackout just now and until now, yeah, you can see that, okay, what is very important over here is to draw the setup of our electrochemical cell, which is going to be, you are going to have metal ion half cell, non-metal ion half cell, and ion half cell. So if you go through all these that I have discussed with you, okay, in a previous lecture, metal ion, you see copper rod, okay, copper ion, okay, you can see how it is going to be drawn, okay. And then, okay, non-metal, you can see how it is drawn. Okay, this is going to be with the gas, non-metal being gas. And we also have a situation where non-metal is going to be also solid form. Okay, so that is going to be, you draw accordingly. Okay, you draw accordingly. I'll answer the question in the chat in a while. Yeah. So ion half cell. Okay, you can see we are going to use platinum. Okay, we are using platinum. So all this we have learned. Okay, so I'll try to answer the question in the chat. Hold on. Okay, so for gases, ion half cell, does the platinum have to be fully submerged or partially in solution, partially exposed to air? How about ion half cell? Okay, doesn't matter. Okay, if you look at the to answer that question, if you look at the ion half cell, okay, you see it is going to be fully submerged, okay, fully submerged. If it is going to be, you see how, okay, in this case, if it is going to be non-metal, okay, non-metal and non-metal ion is half a bit, yeah. So it's not really matter. When we mark also, it doesn't, we don't actually deduct mark. Student didn't put half submerged on top, half submerged below. No, we are not going to look that. Okay, we don't say the copper must be fully submerged. Half will be up, half will be down. Up to you. Okay, but according to the example given, okay, you see if it is going to be normal setup, okay, if it is electrode, you see we are going to use metal. Of course, the metal will be half will be at the top. If it is going to be, we are going to measure related to platinum. Yeah, platinum is expensive. Yeah, please remember. So why some students will say why we don't actually put platinum rod like that? Okay, platinum rod is so expensive. Okay, so we don't want to use that. So it's fine. Okay, it's fine to do it in this way. Okay, fully submerged. Okay, so you look at the example. Yeah. Now, so the next question. Okay, you can see an electrochemical cell. Okay, consisting V3 plus and V2 plus. Okay, and another half cell. Okay, so you need to draw. Okay, so to save time, okay, I will actually not draw. Okay, I will not draw, but probably I'll write down. Okay, if they say what you need to do, okay, you need to do. Okay, one is going to be your ion half cell. Okay, so make sure you use platinum. Okay, and then you put the salt bridge. Okay, on the other hand, okay, VO2 plus and VO2 plus. Okay, so you see here, okay, these ions, okay, you have to look at the data booklet. I have taken some the picture of this. Okay, be very careful, okay, when you deal with this, because we don't want you to use the wrong one. Okay, they say this and this. Don't go and do different combination, this one and this one, and then I select this one. No, don't do that. Okay, so this is half cell, one half cell, another half cell. So you look for the equation that involves the both of the ion in one equation, which is going to be this one. Okay, which is going to be 1.00. Okay, so you must be very careful. Okay, so that is the equation that we want to find. But very, very important, once you find out the equation, you will notice that there is going to be H plus. So when you write down, okay, when you do the setup, okay, this is going to be ion. So when you put there, okay, you put the platinum over there, and then when you put this is going to be VO2, okay, plus, and then VO2 plus, okay, you put over there, and make sure you put H plus over there as well. Okay, very important. Okay, once you put that, okay, you make sure that all these three is going to be 1 mole per dm cube. All of them are 1 mole per dm cube. Okay, this is one of the common mistakes that student will make. Okay, they forget to include the H plus. Okay, do remember why this one is important. Okay, I think some of you even ask me, sir, is it matter? Is it fully submerged or not? You are worried because it's 4 marks. It's 5 marks. Okay. No need to worry so much on that. You worry on, okay, whether it's fully submerged or not. Don't worry. You just follow whether you are using the correct electrode. You make sure you include the salt bridge. You make sure you include the proper electrolyte over there. Then shouldn't be any problem. You will get the full mark. Okay, so you just remember that. Okay, so now if I want to calculate the E cell for this, okay, quite simple. You just need to get the V3 plus, okay, and then plus electron to give you V2 plus. So you need to find out what is the E value for that. Okay, the E value, okay, I will look for you, okay, V3 plus electron. Okay, V3 plus electron. Okay, this one. Okay, so negative 0.26. So using this negative 0.26, okay, I'm going to solve this. Okay, so VO2 plus 2H plus electron to give you VO2 plus H2O. This is 1. So if I want to find out the E value, so you find out, okay, which one is more positive. So you tell, okay, this is more positive, they will go to the right. Okay, so this one is going to be less positive or negative, they will go to the left. So if I want to write down, okay, so I will maintain this equation, but this equation I need to rewrite V2 plus, okay, to give you V3 plus electron. So this is going to be plus 0.26. Okay, just to save time, I'll just use these two. Okay, you add, okay, these two you add is 1.26 volt. Okay, so 1.26, and make sure you write down, yeah, the working. Okay, very important. And then write the ionic equation. Okay, the ionic equation is, okay, electron and electron will cancel. Okay, therefore the ionic equation is, okay, you will write down, I write down VO2 plus, okay, plus 2H plus, I combine, yeah, V2 plus to give you VO2 plus, okay, plus V3 plus, okay, plus H2O. Okay, so this is going to be the equation, okay, the half equation, the ionic equation for this. Okay, Mr. Gopi, do we need to actually write down the state? If, okay, always I tell you, if you have that doubt, okay, no need to ask me, just straight away write down. Okay, 2H plus. Okay, so aqueous, okay, aqueous, liquid. Okay, so you just write down. And then draw the label diagram. Please draw yourself. Yeah, I already give you the important information over there. Now, if you look at the next question over here, okay, you see here we want to complete, okay, we complete the table with the substance used to make the electrode. Now, do remember, this is ion-ion, okay? If you have ion-ion, the electrode is not Fe. Please remember that. It's not Fe. The electrode is going to be platinum. Always remember, it's platinum. And then CO2 plus and cobalt is a metal ion. So you must use cobalt, the metal itself. Okay, that's why, okay, I told you, okay, please use platinum, because they will ask, okay, in the question. Yeah, so they do ask. So write the equation for the overall cell reaction. So first of all, you find out the standard reduction potential half equation, and then you write, okay, I found out already. Okay, and then I want to find out, okay, which one will go to the right. This is going to the right. This is going to go to the left. I want to calculate, okay, write the equation. Okay, so you write the equation Fe3 plus electron to give me Fe2 plus, and cobalt is going to give me cobalt 2 plus 2 electron. Okay, this one stays 0.77. This one is positive 0.28. Okay, 2 electrons, so 2, 2, 2. Okay. So I will have 2 Fe3 plus, okay, plus cobalt to give me 2 Fe2 plus cobalt 2 plus, okay. And this one, if you add, okay, you are going to get 0. This one is going to be 15, so 1.05, okay, positive, okay, positive 1.05. Show the, okay, way how you get. And this one is going to be, you can rewrite, okay, what you have, 2 Fe3 plus cobalt to give you 2 Fe2 plus cobalt 2 plus. Don't worry about this, the one that if you couldn't finish writing and so on, don't worry, I will give you this later, yeah, the written version. Now, so the next question is, okay, the electrochemical cell, okay, in D was set up again. Okay, but now the cobalt concentration is not standard condition. They have given you the cobalt concentration is less than 1. Okay, if it is less than 1, okay, always remember this one thing. Okay, if you have, okay, like for example, cobalt, yeah, earlier under standard condition, you see negative 0.28 under standard condition. Now, if you decrease the concentration of cobalt, what will happen? We know according to LCP, the position of the equilibrium will be shifted to the left to increase the cobalt concentration. When it goes to the left, this value will become more negative. Okay, this is prediction. Okay, but they want you to calculate. How do you calculate? Okay, you use Nernst equation. Now, for this Nernst equation, okay, they have given you in the question itself. Okay, they have given you, and then you just need to use them. Okay, you just need to use them. So I'm going to use, okay, because earlier, okay, I'm going to have negative 0.28. It's supposed to be more negative, okay, but let's find out, okay, when we calculate. So E value, okay, is going to be E standard. You use the E standard, which is going to be negative 0.28. Do not go and use the value that you calculated over here, 1.05. That is the cell value. You do not use the E cell. You use the E standard for that electrode alone, okay, cobalt. Okay, so you use, okay, negative 0.28, okay, and then plus, okay, 0.059, and then the Z is going to be cobalt 2 plus 2 electron to give you cobalt 2 moles of electron. So that is going to be 2, and then log, okay, cobalt 2 plus is given 0.05. They have given you the equation, but do not expect them to give you equation all the time. If you calculate this, okay, you are going to get, okay, this value, which is going to be negative 0.32. And you can see this value, negative 0.32, is more negative than negative 0.28. So it proves, yeah, your prediction. This is just now, okay, the question that was asked earlier. You see, can we use some other electrode? You see, platinum can be used. And I say that there is no problem using carbon or graphite. Okay, no problem. Okay, but I will encourage you to use platinum for ion. Yeah. Now, suggest how this change will affect the overall cell potential. This one, how will it affect? To do this, there are so many ways. Okay, I will prefer to use the main full equation way. If you have cobalt 2 plus decrease according to LCP, okay, the position of the equilibrium will be shifted to the right. When the position of the equilibrium shifted to the right, earlier is 1.05, you are going to have, okay, the E value more than 1.05. So the value is going to be more positive. Okay, that's going to be the answer. Okay, but if you want to find out using calculation, also can. Okay, nobody said cannot. Okay, you see, if you calculate and you get negative 0.32 over here, okay, negative 0.32. So if I want to find the E value, the total E value, yeah, this one, they will go to the right. This one will go to the left. So it's going to be positive 0.32. You want to calculate, also can. Okay, you will get 9, okay, 1.09. So earlier is positive 1.05, you have positive 1.09. Some students, they like to calculate exact value. Yeah, you can calculate exact value, but still, okay, if you compare 1.05 and 1.09, yes, it's more positive. Yeah. Now, the next question is going to be constructing an equation, okay, for the reaction of excess iron 3 with vanadium metal. This one, you need to go and look at the value, okay, for the E value for the Fe3 plus and vanadium. And I told you, okay, when you want to write the equation or predict whether there is an equation and so on, you remember 0 and then the top is positive, you rearrange, and then the bottom is negative. And you remember SOA on the left top, okay, you remember SRA at the bottom right, okay, and SOA and SRA can react. And if you arrange, you see this is positive, this is negative. No need to rearrange. It's on top, left, okay, on top and then at the bottom. This is going to be your SOA. This is going to be your SRA. Fe3 plus is a strong oxidizing agent. They can oxidize vanadium. Okay, this is how you use. Okay, and there are two methods, and I think this method is more suitable for this. So they say write the equation, construct the equation. Quite simple. Okay, construct the equation. So what will happen? Okay, you just need to find out this is positive. Okay, Fe3 plus. Okay, they will go like normal. Fe3 plus electron to give you Fe 0.77. Okay, and then you just need to put vanadium to become vanadium 2 plus. Okay, positive 1.20. Okay, equation you need to write times by 2. Okay, so you will get this. Okay, and you will add up. Okay, you will get 2 Fe3 plus. Okay, plus vanadium to give you 2 Fe plus vanadium 2 plus, and the E value. Okay, if you add, you will get 1.97, which is positive. You see, the reaction can happen. Okay, feasible. Okay, so they didn't ask you to calculate. Okay, but you can use the concept. So now, okay, if you look at it, okay, how did I do that? Okay, this is going to be, okay, this part. Okay, now, why the marking key actually asks us to use KVO2 instead of, okay, this one lack of time. Maybe later I will try to answer Shannon here. Okay, now If you do the feasibility method, yeah, two methods, okay, okay. And then how to predict, we have done this, okay, you must actually, it's valid if it is going to be greater than 0.3. We have done about Nernst equation, okay, and there is going to be this part, okay, that we couldn't cover in the previous lesson, okay, but I have done a video on this, okay. You can also go through this. The formula is going to be Gibbs free energy is negative NFE, okay. N is being to be the number of moles, okay, of the electron. Yeah, so this is going to be very important, okay. So if you look over here, okay, you can actually try to solve this, okay, and you can tell, okay, whether the reaction is feasible or not, okay. And this is going to be important, okay, where I have shown you in the video, okay, because the N is not always going to be just like this 2 moles only, okay. N can be also 6, okay. You can just go through under the extension over here, okay. If those of you who wants to find out more, yeah, it's inside this video, okay. The link is there, and there are some revision questions with the marking key, okay, and some discussion as well, okay. If you want to go through, yeah, you can go through. And here, okay, the last part that I want to mention is this is our syllabus, and we have covered all this, okay.